Okay, in this video we'll see the transformer turns ratio measurement using AC bridge. Now if you see the circuit required for this transformer turns ratio, now it is like this. Here you can find two transformers. One is transformer under test and second one is a standard transformer. So the tappings of this standard transformer can be varied. So by taking that variation of the voltage, now we can get the turns ratio. Now here you have a AC voltmeter. The AC voltmeter will measure the difference of these two voltages. So now if you see the turns ratio is like this. So the turns ratio is N1 by N2 is equal to the 230 volts. That 230 volts is a fixed AC supply voltage what we are giving on the primary side by the VA, that is a secondary voltage of the transformer. So and if you see the tappings are like this: 14 volts, 13 volts, 12 volts, 11 volts, 10 volts, 0 volts. Okay, by taking these tappings, you can find the difference of voltage between these two transformer secondaries. So you can have a tabular column like this. The tabular column is serial number, to tapping position and AC bridge voltage. When you connect to 0 volts, you can see how much voltage is going to be appear. When connect to 10 volts, what is our voltage? 11, 12, 13, like that. So if you want that AC bridge voltage, theoretically you can calculate like this. This VA is the voltage appearing across the secondary winding of transformer under test. VB is the voltage across the secondary winding of the standard transformer. So that VA is equal to AC bridge voltage plus VB. As you know that VA voltage, you can see under test you have by connecting a multimeter we can find the voltage across this terminals of a transformer. You can find it as 12 volts. Let me see how it is going to be appear. If you check the secondary voltage of a transformer under test, now it is 230 to 12 volts transformer, you can find the voltage that is 12 volts. Now you can vary the tappings of this transformer. Okay, by varying the tappings of the transformer you can find the variation of the voltage. So we'll see the variation of the voltage with respect to these tappings like this. See, now here the connections are very simple, it is very easy. So here you can see this two. Okay, now this is one terminal which is going to be connected to this. Now because we need to provide some connections to this, so here you can connect, and another terminal. Now we are going to vary the number of turns on the secondary side of this standard transformer. So that's why I just connected here. I have taken this other end as a free to change the terminals. So when you turn on this, see, you can find the tappings 0, 10, 11 volts, 13 volts, like that. So if you check the voltage here, it's very simple. You can find this will be 12 volts. If you want, you can observe here, this is 12 volts. So when you check the voltage at this position at 0 volts, so at 0 volts that means this is a tapping, that means we are taking a complete winding of this transformer. So in that case actually here these two are internally connected. So 12 volts and 12 volts, so you have taken only the 0 volt, 0 tapping. 0 tapping means we are not going to consider the winding of the standard transformer. So that's why this voltage is 0. That so AC bridge voltage, if you see the formula, AC bridge voltage is equal to that VA minus VB. So this VB voltage is anyway 0. So the VA voltage is whatever the voltage appearing across the transformer, that is 12.63, that is nearly 12.7 that we are getting here. Now by changing this terminal, now instead of 0 volts, if I connect it to 10 volts, okay, 12 minus 10, we will get the difference as 2. Yes, Is it okay? See here the formula, same formula, whatever we used earlier. VA is equal to AC bridge voltage plus VB. AC bridge voltage is equal to VA minus VB. So that VA minus VB is going to be appear across here. That is 12 minus 10. Next, you can see the voltage of 11 volts. So it is a small voltage, 0.8 is going to be appear. Okay, now that is nearly 1. So 12 minus 11 is 1. Next 12 minus 12. Here you will get it as a 0 because VA voltage is 12 and VB voltage is also 12. 12 minus 12. Yeah, bridge is balanced. So when the bridge is balanced, the voltage is equal to 0. Next is at 13 volts. Yeah, if you see that 13 volts, again you will get the difference as 1. So it will show it as a 0.8. For 14 volts, it will be equal to 2. So now these are the variations of these voltages with respect to the tappings. And if you want the turns ratio, you can take the turns ratio, that is N1 by N2, that is 230 is fixed primary side, and the secondary side N2 will be varying depending on the voltage VA. So that voltage variations, if you want, you can see that 10 volts, 11 volts, 12 volts, 13 volts and 14 volts. By taking that difference of voltages, you can find the turns ratio. Now if you take that VA as a fixed 12, 230 by 12, then you will get the turns ratio. Okay. Now this is about the measurement of turns ratio by using AC bridge.